Half the spoonful of ice cream you ate last night, by volume, was air. Try this tonight. Pour heavy cream, straight from the carton, into a tub. Slide it into your freezer. Come back in the morning. What you'll pull out is an ice cream. It's a hockey puck. A pale, dense, spoon-bending brick. Same cream, same water, same sugar if you whisked some in. And yet, the scoop at the store tastes like a cloud. Something is different, and it isn't the cream. Not the fat, not the water, not even the sugar. Something is hiding in plain sight. So here's the puzzle. How does the same cream become a brick in one freezer and a cloud in another? The answer is that ice cream isn't really frozen at all. It's something stranger and a lot more clever. If it isn't frozen cream, what is it? Slice a spoonful in half and look closely, really closely, and you find 4 very different things sharing the same space. Tiny shards of ice, a net of fat globules, a sticky syrup that never froze, and, surprisingly, a forest of air bubbles. The ice crystals are about the width of a human hair, small, but you can almost picture them. The fat globules are 100 times smaller, all clumped into a stretchy net. Threading between everything is a syrup so sweet, the water trapped inside it can't even freeze. And the air? It's the biggest of them all. Bubbles 10 times wider than the fat, woven through the whole thing. Add it up, and a typical scoop is roughly half air, a third ice, with fat and syrup filling the rest of the gaps. 4 faces, 1 spoonful. That isn't a frozen food, that's a composite material. But here's the part that should break your brain. Your freezer is colder than the inside of a meat locker. And yet, about a third of the water in that tub of ice cream is still liquid, right now, sitting in your freezer. The trick is sugar. Pure water freezes at 0. Sugar water doesn't. Dissolve enough sugar and you can drag the freezing point down to -20, -30, even further. Scientists call it freezing point depression. Your tongue calls it, why isn't this a brick? Here's where it gets sneaky. As pure water freezes out into crystals, the syrup left behind gets more concentrated and harder to freeze. About 70% of the water gives up and becomes ice. The other 30% stays as a thick, hyper-sweet liquid forever, coating every crystal. That syrup is the secret. It's why your spoon goes in. It's why a brick of pure cream wouldn't. And the strangest thing about that trick, you only have to lose it once, but we'll come back to that. Sugar buys you a scoopable texture. It doesn't buy you a creamy one. For that, you have to win a war against your own tongue. Your tongue is a surprisingly good microscope. It can feel a single ice crystal, if that crystal is wider than about 50 micrometers. 50 micrometers, roughly the diameter of 1 strand of hair. Below that line, your tongue can't resolve it. Smooth, cold, soft. Above it, every crystal is a tiny rock. Gritty, icy, coarse, the kind of bite that ends a dessert in a single second. Food scientists actually freeze sample after sample, peel them apart under a low-temperature electron microscope, and measure every single crystal. The graphs are stark. Smooth ice cream sits between 10 and 45 micrometers. Anything that drifts past 50 falls off a cliff into unpleasant. Which means an entire industry, every churn, every stabilizer, every freezer in every factory on Earth, is fighting one single battle. Keep the crystals smaller than 1 strand of hair. Always, forever, or your tongue catches you. And we'll see in a minute how easy it is to slip up, and how unforgiving that 50 micrometer line really is. So how do you actually win that war? The first answer was patented in Philadelphia, almost 200 years ago. September 1843. A woman named Nancy Johnson files U.S. South Patent number 3254. Her invention looks unremarkable. A metal cylinder of cream, surrounded by a jacket of crushed ice and salt, with a hand crank turning an S-shaped paddle inside. The paddle is everything. As cream touches the freezing wall, ice crystals try to grow, and the paddle instantly scrapes them off before they can. Tiny crystal, scraped. Tiny crystal, scraped. Thousands of new little crystals every second while the cream keeps moving. And as the paddle turns, it whips air into the mix. The same air that ends up filling half your spoonful. Nancy Johnson didn't invent ice cream. She invented the machine that hides the ice and that quietly kicked off the entire modern industry. Today's factories take her trick and crank it to 11. Continuous freezers, plant gums to slow crystal regrowth, blast tunnels at -40 to flash freeze the rest. Every machine, every gum, every cold room exists to keep those crystals from ever crossing one stupid little line. 50 micrometers. And here's where the story turns a little dark. The whole structure, the tiny crystals, the fat web, the trapped bubbles, only holds together as long as the cold holds. Let it warm up, even once, even just a little, and something quiet and irreversible happens. When ice cream softens, the smallest crystals melt first. They're the least stable. Refreeze the tub, and that meltwater doesn't make new tiny crystals. It deposits onto the bigger crystals, making them bigger still. Scientists call it Ostwald ripening. Big crystals eat the small ones, always in the same direction. Researchers have actually filmed this happening frame by frame under X-ray microscopes. Cycle after cycle, the small crystals quietly vanish. The large ones swell. And once they cross 50 micrometers, your tongue feels it. From that moment on, forever. The microstructure can't be put back together. Not by your freezer. Not by patience. The only way back is melting the whole tub down to liquid and re-churning it under a blade. Which means every refrozen tub on a grocery shelf is, microscopically, a one-way door. You can taste the thaw because the small crystals are gone. So go back to that brick in your freezer. It's still the same cream, the same fat, the same water, the same sugar even, if you added it. But there's no paddle scraping crystals off the wall. No stabilizer slowing them down. No blast of cold pinning them in place. No bubbles holding the structure open. And every crystal grows and grows, past 50 micrometers, past 100, into one continuous sheet of ice, which is the technical name for a hockey puck. Ice cream isn't a frozen food. It's a 4-phase composite material, half air, a third ice, the rest fat and syrup, held together by a war we've been fighting against our own freezers for nearly 200 years. Your tongue happily believes the smooth lie, and tonight when you take a bite, you'll know exactly how that lie was built.